Hello everyone, welcome to LX518. So today my topic is about our sharing for our successful repair story for one of our semiconductor equipment. Alright, so for the background, I will give you directly the background. This equipment is used for wet gate clean strip process for semiconductor wafers. And this equipment is already over 25 years running in the production. So the management plan to de-invest this equipment due to frequent failures, instability of the equipment, and also there's no OEM support as it was purchased from the third party and that company has already dissolved, right? And for the motivation for this topic, of course, is the replacement of this equipment would take 2 years or more due to upper level approval and alignment with the vendors. And the second motivation is we want to run this equipment even at minimal output until the new equipment is available. Alright? So stay tuned. The details are coming up right now. Here are the list of the major failures we encountered and fixed. I will share the details of each item, hoping you guys can learn something from them and gain valuable insights from our experience. But before I proceed, I want to highlight that the previous engineers, the equipment owners, had already spent a significant amount of time trying to fix the equipment, but did not have much luck recovering it. Despite their efforts, the issues remained unresolved, which led them to call our team for assistance. At that point, we had a strong suspicion that they had already messed up the equipment in their attempts to troubleshoot it. However, as one team, we knew it was our responsibility to step in and do everything we could to bring back the equipment to working condition. The situation was a true test of our skills, patience, and teamwork. Regardless of the challenges we faced, we remained committed to solving the problem together. That's what real teamwork is all about. Let's go. The first issue we prioritized to fix was the missing alarm information. When the alarm window popped up, it displayed only a white screen, and the messages were missing. As a result, we had no error information to troubleshoot the issue. During our investigation, we discovered that the master PLC has 4 stations, and we accessed the information using Melsec software. The details in item 1 showed that station 3 was highlighted in red, indicating it was disconnected. Station 3 is responsible for handling alarm information. However, as shown in item 2, the station selector was set to station 13 instead of station 3. After correcting the setting to station 3, the issue was resolved, as shown in figure 1.2. Thank you. The second issue we encountered was that the stacker robot moved by itself when the DC subsystem was powered up. This was the most challenging failure among all the issues we faced and took the longest time to resolve. The image on the left shows the actual photo of the stacker Z-axis robot and the problem with its forward movement direction. The cause of this unintended movement was excessive grounding on the signal cables. We discovered that A previous engineer had added extra ground wires, believing that more grounding would help eliminate noise. However, this had the opposite effect. Too many ground connections created ground loops, generating unwanted signals strong enough to trigger the Z axis to move forward on its own. Item 1 illustrates the block diagram of the PLC positioning module AD71, motor driver, and the stacker Z robot. By removing the extra ground cable from the signal lines, as shown in item 1, we successfully resolved the problem. Thank you. Alright, so what is ground loop? A ground loop, an electrical system occurs when multiple paths for electrical current flow exist between 2 points intended to be at the same ground potential, leading to unwanted current flow and potential issues like noise or interference. When interconnected devices have multiple paths to ground, a loop can form, allowing current to flow between them even when it shouldn't. Thank you. The third issue also involved the stacker Z-axis robot, as shown in the image on the left. The backward movement speed had been jag speed, a lower speed in the AD71 module. We asked around to determine who made this adjustment, but no one knew. We conducted several studies and attempted to access the AD71 module, but had no success at all. Since we couldn't make progress with AD71 at that time, we shifted our focus to finding a containment solution. Fortunately, after analyzing the main PLC ladder diagram, actually, my first time working with a ladder diagram, we discovered that the backward movement timeout error was set to a default 20 seconds, as shown in item 1. Through the timing experiments, we concluded that increasing the timeout error from 20 seconds to 30 seconds could compensate for the delay and prevent the timeout alarm until the robot's backward movement reached the home position. While this adjustment did not fix the root cause of the problem, but it served a temporary workaround to avoid the timeout error. Great, thank you. Failure number 4 is also related to timer, where the heater is supposed to turn on when chemical exchange process step is detected. Shown in the left image, based from our counting, it took 3 hours before it turned on. This is too much waiting. Then again, we investigated the recipe parameters and found out that temp count of T value was set to 9999 seconds or 2.7 hours. Wow! Reviewing the old log copy, we found that the correct value should be 1800 seconds or 30 minutes. Again, no one knew who previously played with the values. Anyway, we are here to help and resolve the problem. Great, thank you. Alright, so that's all for the failure and fix info sharing. I'm happy and hoping you guys can learn something. And I'd like to thank you to the equipment owner for giving us the opportunity to help. And the equipment has generated 61 million euro in output over the past 13 months. And thank you to the management for recognizing our efforts. And finally, most important, thank you to my boss for giving me a 2000 USD spot cash reward money. Thank you, boss. That's cool.